Welcome back, everybody, to another Swift programming tutorial. This is part 15 and the last tutorial in our basic series. In this tutorial, we're going to go over enumerations, often called enums or enums, depending on how you want to pronounce it. Before we get started, let's go over a few notes. When and why would you want to use enums? Enums can be used when there is a set number of related data items or values that you want to group together in a common type, to help prevent errors with typing, and to help standardize or provide consistency in naming of different types of data in your code. A typical example of how you would use an enum is you would create the enum, then you would create a variable and assign a case from the enum, then you would use a switch to do something based on that variable. Enums are very flexible and powerful in Swift, and we have a whole bunch of examples to get through, so let's go ahead and get started. To create an enum, you use the reserved or keyword enum, then give your enum a name, and it is typically capitalized and in singular form. And you put it in singular form so that when it's used, it is more accurately descriptive of the value in your enum. Inside your enum curly brackets, you want to go ahead and create your values, and to do that, you can type out case, and then give your value a name. In this enum, we want to put the different directions, such as north, south, east, and west. Now we can take the values from this enum and assign them to a variable. In this first example, we're going to make the type for this variable the enum itself. Then we can assign any value from that enum that we want using a dot. Now, one thing that's really cool is whatever values are in that enum will pop right up, and then we can select whatever we want. Another way to assign a value from the enum is to create a variable name. Then you can assign the enum name, and then use a dot and choose whatever value you would like. Let's go ahead and use a print to display the values. Let's run it. And you can see down here in the console, using the two different ways to assign values from the enum to variables, we get the same output, west and west. In our next example, let's go over how you can access number values associated with an enum using the raw value. Okay, so we create our enum, and notice that we give it a type of int. Now we can create our cases. And in this example, we're just going to use the case reserved word once, and we're going to put all of the names on one line. So let's go ahead and assign our int value, and let's give Monday 1. Now in this case, Monday will have a raw value of 1, and the rest of the names will just increment by 1. So let's go ahead and create a variable. Let's make this variable have the type of our enum. Let's access the enum. For this variable, we want to go ahead and assign Monday, so we can use a dot. Let's choose Monday. Let's go ahead and display the value day of week. And let's use a dot to access the raw value. And you can see we get 1 back in the console, which is the raw value that we assigned to Monday. Now if we change this to Tuesday, we should get back 2. Okay, we get back 2. That looks good. Now, one thing to note, you can assign these raw values in pretty much any way you would like. So, for example, we could assign 5, and then increment each one by 5. So now when we run this, since our day of week has Tuesday, and we assign 10 to Tuesday, we should get back 10 down in the console. Okay, we get 10, we're good to go. Now notice in this example, we made this enum of type int. You can also create enums associated with other types. So let's show you an example of one using string. Let's create a variable to hold a value from this enum for our favorite season. Let's use a print to display the outcome. Inside the print round brackets, let's put our favorite season and then use a dot to access the raw value. Now when we run it, you can see we get fall down here in the console. You could also assign different string values to each of these cases, and we'll show you an example of that here in just a little bit. Next up, let's show you how you could initialize from a raw value. Let's create an enum with the Great Lakes. Let's associate it or make it type int. Let's put in our cases. Let's make Lake Superior 1. Then each Great Lake after Superior will increment by 1, so we don't explicitly have to assign the values. Now, earlier we mentioned that enums in Swift are quite flexible and powerful. So another cool thing you can do with enums is you can put functions inside. Let's create a function that will allow us to access some information regarding each enum case. Inside the function, we're going to use a switch. We're going to switch on self. And when you switch on self, that allows you to access your enum and its different cases. What we can do here for the case is just simply use a dot and put in all of our cases. So what we want to do with each case is use a return to return a description for each Great Lake. Okay, so you can see for Lake Superior, we want to return a message that says Lake Superior, largest lake by surface area. Let's go ahead and do the same thing for the rest of the lakes. For this switch, we don't need a default because it is already exhaustive. We have included Superior, Huron, Michigan, Erie, Ontario. So we can go ahead and delete that. Now what we want to do is to use an initializer to find the second largest lake by surface area. Let's go ahead and create our variable. Let's assign our enum Great Lake. And then inside round brackets, let's put the raw value for the second largest lake, which is Huron, because we have gone ahead and put these in order by size. And since each one has an int associated with it, which also correlates to its size, for example, Superior is the largest, it's number 1. Huron is the second largest, it's number 2, and so on. We can put in a raw value of 2. Next, if that value is available, let's extract that value for use as a temporary constant or variable, and if it's not available, let's return a message that says NA. Okay, so if you're not that familiar with this code here, don't worry because we're going to go over it more when we go over optionals. For now, let's just use this comment to help explain what we're doing with this code. Okay, so if raw value 2 is available, let's use a print to display that value along with its additional information that we created here inside our function. If the raw value is not available, let's use an else and a print to display NA. Okay, so let's run this, and we should get back the message in this case. So you can see we get Lake Huron, second largest lake by surface area. That's good. Now what if we put in a value here that does not correspond to any of these values? So we have 1, 2, 3, 4, 5. Let's put in a 6, and since we created an else, here we should get back NA. And we do, we're good to go. Next up, let's go over another enum example that uses a function and a switch. Let's go ahead and create another enum with the seasons. Let's make it have values of type string. And for each case, let's assign a string that describes each season. Let's go ahead and create a function that will add an additional description. Again, we're going to switch on self. And remember, self will allow us to switch on the values associated with the enum we're in, or the enum itself. We want this function to return a string. And now let's go ahead and create our cases. For each case, let's return a descriptive message for each season. Again, we don't need our default because our switch is exhaustive. Let's go ahead and create a variable. Give it the name season. Make it of type enum season. And let's assign spring. Now what we want to do here is show you the difference between displaying the season variable and the season variable's raw value and the season variable description using the function. So let's use a print. Let's put in season. Now let's put in the season raw value and the season description using the function. Let's go ahead and run it. Okay, so you can see our output down here in the console, and for the season we get back spring, and for the season raw value we get back warm. You can see we assigned warm here, and for the season description we get back our description. Spring is beautiful with all the plants coming alive. Let's go ahead and separate this out so we can see it just a little bit better. Let's comment out these prints here. And let's run it again. Okay, so this is a little bit better. We can see each part on its own separate line now. So again, the season is spring. The season raw value is warm. And the season description using the function gives us our description here. Next up, let's go over enums with associated values. Let's go ahead and create an enum that will help us track status of different projects. Let's create our first case, and we'll call it behind schedule. So this would be a case that would give us information on a project that was behind schedule. Now, if the only information you had about a project was that it was behind schedule, that really wouldn't tell you very much. So what you can do with these enum case values is you can associate values with them. And you can think of associated values as stored properties of the enum case instance. Now, to associate these values with these cases, you just create your case name, and then in round brackets, you put the types of those associated values. Now you can just put the types, or you can give them names and put the type. Now we want to be a little bit more descriptive here, so let's go ahead and give them names as well. So the first thing we want to know is the number of days that this project is behind. And we're going to make this associated value a type int. The next thing we want to know is the reason that this project is behind. And we'll make this associated value of type string. The cases for this enum will just have two, and we'll just say that a project is either behind schedule or on schedule. And for the on schedule case, let's just keep the associated value real simple, just in case somebody wants to put in some comments regarding that project. Okay, so now let's go ahead and create some projects and assign their status. For project 1, we're going to use our enum project status. And let's just say that project 1 is behind schedule. So let's use a dot and access behind schedule. And now let's put in our associated values. Let's say that project 1 is 52 days behind, and the reason is supply issues. Let's create project 2. Again, let's use our enum project status. And let's say that project 2 is on schedule. Let's just put in a comments message, no issues, good to go. Now project 3 is also behind, but it's only 3 days behind. And the reason, there's no real issues, and we'll be caught up soon. Now let's go ahead and put these projects in a dictionary so that when we want to access them, we can access them by name using the key. So the key for the dictionary will be string, and the value will be of type project status, which is our enum. Okay, so now we have all of our projects in our dictionary. The next thing we want to do is list all of the projects with their status. So let's go ahead and use a for loop. We'll say for key value in all of our projects. You don't normally sort dictionaries, but since we have these projects listed by a name with a number, let's go ahead and sort these. So let's use sorted. And let's use a closure. Don't worry about this syntax too much right now. We'll go over closures in the near future. And we want to sort by the key smallest to largest, so it should be in the order of project 1, 2, 3. Let's just do a little check to make sure that our dictionary is not empty. So we'll say if all projects is not empty, so we'll use the exclamation to say not. All projects is empty. So this looks a little bit funny, but this should test our dictionary to make sure it's not empty. Now let's go ahead and use a print to display the project status. We're going to use string interpolation. Let's put in our key. Then let's use string interpolation again and put in our value. Let's go ahead and try and run this and see what we get. So you can see down here in the console, for each project, we get the status. Project 1 is behind, 52 days behind, and that's because of supply issues. Project 2 is on schedule, no issues, and Project 3 is just slightly behind, no real issues, will be caught up soon. Moving on to our next example. So in this example, what we want to do is create an enum that tells us travel distance and times. Let's just say that there are 3 places you love to go to, and there are 2 places that you typically start off from when you go to these 3 places. And those would be your home or work. Let's go ahead and create our enum. We'll call it place to visit. Let's make it type string. And we're going to have 6 cases. And as we mentioned, there are 2 start points, your home and work, and there are 3 places that you go to. The 3 places that you go to are the dog park, the Frisbee golf course, and your favorite place to eat. So let's go ahead and create those cases and give them an extra string descriptor, raw value. Now, I just realized that you couldn't go from work to the dog park because you'd have to pick up your dog first, but let's just go ahead and go with it. Okay, so we have gone ahead and created our 6 cases, and what we want to do is create a function that will help remind us when we visit each of these places, the distance in miles, and the travel time in minutes. Okay, so our function will take no arguments, and then it will return the distance in miles, which will be type double, and the travel time in minutes, which will be type int. Let's go ahead and use a switch. We're going to switch on self. The first case is home to dog park. And let's return the distance in miles, which is 5, and the travel time in minutes, which is 10. Let's go ahead and do the same thing for the rest of the cases. Since we mentioned that we can't go straight from work to the dog park without our dog, we went ahead and added some extra time to pick up the dog. And the miles shouldn't really change that much because let's just say that it's on the way. We have created all of our cases, and each case will return the distance in miles and the travel time in minutes. We don't need a default case. Let's go ahead and create a variable, place. Let's use our enum, place to visit, and let's use a dot, and let's put in home to dog park. Let's go ahead and use a print. Let's access our place variable, and let's use the raw value to give us our description. Let's access our place variable again, and let's use our distance function to give us our distance in miles and travel time. Let's go ahead and run this and see what we get. Okay, so you can see down here in the console, we get our raw value description, home to dog park, and then we get the output from our function, which gives us the distance in miles from home to dog park, which is 5, and it should take us about 10 minutes to get there. Next up, let's use an enum to help us create a little mini calculator. Let's create our enum and call it math operation. And this little mini calculator is going to be real simple. It can only do 4 things. It can add, subtract, multiply, and divide. So our first case is going to be plus. It's going to have 2 associated values. Let's go ahead and give our first associated value a name, number plus 1. It's going to be of type double. The second associated value will be number plus 2. and it will also be of type double. Let's create 3 more cases for subtract, multiply, and divide. Let's go ahead and create a function that will allow us to perform our operation. It will take no arguments and return a double. We're going to switch on self. Our first case will be plus. Now we need to put in some values for our associated values. So let's go ahead and create a little note. So what we can do for these associated values is we can use let and then some name. And we're just going to use let x and let y. And this will allow us to extract the associated values and then use them in our math operation cases. So let's put in let x, let y. And since this is plus, then we're going to return x plus y. Now we can do the same thing for the rest of our operations. Okay, so if you ever forget what to put in for these values, for the associated values, just refer back to this note. Let's go ahead and delete our default. Let's go ahead and test out our little mini calculator. Let's just create a variable, plus. Let's use our enum, access the plus, and let's put in the 2 values we want to add together. So let's put in 4.5 and 5.5. Let's use a print to display. Now when you put your variable inside the print, remember to use a dot and access the function. Perform operation. So 4.5 and 5.5 is 10. Let's go ahead and run it, and we should get back 10 in the console. Okay, we get back 10, we're good to go. Let's test out our other operations. So we have 20 minus 40, 5 times 5, and 45 divided by 15. So we should get back negative 20, 25, and 3. Let's run it. We get back what we expected. Everything looks good. In our last example, let's go over how to use an enum within a struct. Let's go ahead and create our struct. We'll call it movie. And inside the movie struct, we're going to put a couple enums that will give us genre categories and ratings for movies. So this will be the genre enum. And let's create cases for comedy, action, and science fiction. Our next enum will have the typical ratings for movies. Let's go ahead and create our variables for our movie struct. And when we create our instances from this struct, we want to have a movie name, and then of course the genre and the ratings. The movie name will be of type string. The genre will use our enum type, genre. And then the rating will use our enum type, rating. So let's go ahead and create our first movie. And the name for this movie is A Great Movie. Now what's really cool here is we can just simply use a dot to access the different genres. So let's say this genre is action. Now again, for the rating, we can use our enum and use a dot. And this one is PG. Let's create our movie 2. And the name for this movie is Another Great Movie. The genre is science fiction, and the rating is PG-13. Let's go ahead and loop through and display our movies. And let's use a print to display the movie name, genre, and rating. Let's go ahead and run it. Our first movie, A Great Movie, has the genre action and is rated PG. Our second movie, another great movie, has the genre science fiction and is rated PG-13. Okay, so that's all we have for this tutorial on enumerations. We will be doing many more Swift tutorials in the near future. Join us for those, and we'll see you next time.